Okay, Bismillah. We continue our review for the midterm. And this question, it says here the following is the number of daily reported cases. He wants the sample standard deviation. So we said yesterday we could create frequency distribution. This is xi, this is I. We could of course do it normally, but I have 5. It's repeated 3 times. 1, 2, 3. And I have 6 repeated 2 times. 1, 2. I have 7 is repeated only 1 time, and 8 is repeated only 1 time, and 9 it's only 1 time, and then 12 only 1 time. Now, what do I need for standard deviation? We need first to find the variance. That's, we say that's s squared, and the rule says n sum of the frequency times xi, frequency the square times the frequency minus the square it's the square. Second. Not responding. Close it and then you will. Close it. Okay. Now, as I said, we want to find the sample standard deviation. We need to find first the variance, and the variance is defined by n times xi xi squared times the frequency minus the square of the frequency times the element, all squared, divided by n times n minus 1. And remember, it's actually n, it's the sum of the frequency. So here we go. That's what we have. We have xi, we have the frequency, we have the elements xi times the frequency, and we have xi squared times the frequency. That's the table we would like to create. Now, I have 5, it's the 3 times, so it's 5 times the 3 is 25, and 5 squared times the 3 is 75. And I have 6 appearing 2 times, 1, 2. So 2 times 6 is 12. And 6 squared times 2, 6 squared is 36 times 2 will be 72. And we have 7 appearing only 1 time, so 7 times 1, it's 7, and 7 squared times 1, it's 49 times 1, which is 49. And we have 8 appearing only 1 time, so the frequency is 1, and 8 times 1 is 8, and 8 squared is 64 times 1 will be 64. We have as well 9 appearing only 1 time, so 9 times 1 is 9, and 9 squared times 1 it's 81. Then we have the last number, which is 12, and the frequency is 1 because it's appearing only 1 time. 12 times 1 is 12, and the 12 squared is 144. Of course, the frequency is 1, that's why. Now we need the sum. We need the sum of what? We need the sum of the frequency because it will give me n, and the sum of the frequency, it's 9. And you might see it even in the statement here, it says 9 days. We need also the sum of xi times the frequency, which is 63. And we need the sum of the square times the frequency, which is 485. So if we want to find the standard deviation, we will find the variance first. N, as we said, it's sum of the frequency, which is 9. Then times the sum of the squares times the frequency, which is 485, minus the square of 63, which is actually xi times the frequency, divided by 9 times n minus 1, which is 8. So that will be equal to, be careful, he is not asking about the variance, he is asking about standard deviation. So what I have is 9 times 485 minus 63 squared divided by 9 times 8. That will give me 5.5, but that's not our answer. Be careful, even if it's written here 5.5, that is not our answer. Our answer is a standard deviation, which is square root of the variance, square root of 5.5. So square root of the answer that will be equal to 2.34520788. But when you look here, you have two digits only. So if we go to two digits, actually there is a mistake here. Two digits will be, if this is 5, we add 1 here, so it will be 2.35. So that will be 2.35, not 4. So that will be the right answer. Okay, it's a typo mistake. When you want to round, you look for the number after 4. If it is 5 or more, you add 1. So it will be 2.35. Now, here is a group data. What's the difference between a group data and a group data? The difference only, we will find first the midpoint. So midpoint, we call it XM, which is midpoint. So how to find the midpoint? To find the midpoint, quickly, first of all, the first one, the midpoint of the first one, it's 20 plus 30 divided by 2. So that will be 50 divided by 2, which is 25. So once we get the first one, 25, and we know the class width, it's 40 minus 30. 40 minus 30, it's 10. So the next one, we just add 10. So 25 plus 10, it's 35. Plus 10, it's 45. Plus 10, it is 55. Then plus 10, you will get 65. Of course, you can check any one of them, like for example, the last one, if you want to check, it will be 60 plus 70 divided by 2, and that is 130 divided by 2, which is 65. But only if you are careful. In the first one, you add the first two and divide, then you get the difference 40 minus 30, which is 10. So the class width is 10. Of course, you can get it also from 30 minus 20, which is 10. So once we know the class width is 10, so the difference will be 10 all the time. Now, let me remove this one. I need the space. What do I need also to find the sample variance? I need the frequency times the midpoint. I need the frequency times the midpoint. And if we multiply the frequency, which is 9 times 25, what we will get? 225. Then 4 times 35, we will get 140. And the 3 times 45, we will get 135. And 2 times 55, we will get 110. And we have 2 times 65, which is 130. What else we need? We need in the formula also xm squared times the frequency. So that means squaring 25 times 9. So what you will get if you square 25 times 9, you will get 5625. Then 35 squared times 4, and you will get that is 4900. Then 45 squared times 3, and you will get 6075, and so on. It will be 55 squared times the frequency, which is 2, and what you will get 6050, and the last one 65 squared times again the frequency 2, and what you will get is 8450. Now we need to find the sum. Of course, I need the sum of the frequency, which is 9 plus 4, that's 13. 13 plus 3 is 16, plus 4, that's 20. And also, we need the sum of that column, which is xm times the frequency, that is 740, and the sum of squared times the frequency, which is 31100. Once we get that one, we could answer all the coming questions. So the sample of variance is squared is equal to n sum of xm squared times the frequency minus the square of the sum xm times the frequency all squared divided by n times n minus 1. And remember, n is actually the sum of the frequency, which is 20. So that will be 20 times 31100 minus the square of xm times the frequency, which is 740, divided by 20 times 90. That will be equal to, if we put it in the calculator, we will get that is 20 times 31100 minus 740 minus 740 squared divided by 20 times 19, and that will be equal to, in the calculator you will get 195.789473. If you look in the choices, you have 2 digits. So if you go to 2 digits, you look for this number. If it is 5 or more, you add 1 here. So it will be 195.79. So the answer will be B. That is the variance. Now, next question. The next question, it's the same question, but he wants standard deviation. So standard deviation, so see the calculation in question 27. It's the same calculation. So the standard deviation, it's square root of the variance. There he is asking about the variance. Here we are asking about standard deviation. So it will be square root of 195.79894737, which we calculated from the previous example, and that will be square root of the answer of last question. So we will get 13.99247918. But if you look here, it's only 3 digits, so you want only 2 digits. Sorry, 2 digits. So we look at the third one. It's 2 smaller than 5, so we just say that is 13.99. So the answer is that. Now, that's if we have a group data, we need to find the only difference, we need to find the midpoint of each interval. Now, okay, guys. Now, here it says listed below are the time in minutes. For example, 16 customers had to wait at the local sandwich shop before their orders. Were processed the first now. Now, the question is, what is the first quarter? Here should be list up. So he's asking the first quarter is. The first quarter is. How to find the first quarter? To find, this is speaking about the formula, which gives you the location first of the first quarter, which is LB. We need your attention here. It's N plus 1. It's the percent over 100. Before you answer this question, you need to rearrange your numbers here in order. So what I have here, I have the smallest number is 5. So it's 5 appearing how many times? Appears here 1, this is second, and I guess need to move it little to the left. Okay. It's not showing all the screen. So we have, anyway, we have 5 2 times only. Then we have 6, then 6 again 2 times, that is 6 and 6. It seems to me that's all the table. Then we have 8 3 times. No, there will be somewhere there. 8 and 8 and 8. That's 3 times. These here 2, and there will be 1 in the right. It's not showing. Okay. And we have 9 2 times. And we have 10. 9 2 times. We have, here is 1, and here, so there will be 1 there. And we have 10 only 1 time. That's the 10. Then I have 11 2 times. This is one of them, that's the second. And we have 14 2 times. This is 14. I guess there will be, yeah, that's the second. And I have 15 and 16. 15 1 time, 16 1 time. Anyway, there is a column over there which contains 8 one more time, and it contains anyway 1 of them. So these are the numbers. We have to list them in order first to answer this question. We have to put them in order from smallest to largest. Now, If I want to find the first quarter means 25%. The location is 25%. So if we calculate 25%, so that means B is 25. So that number of elements here we have 16, sorry. 1, 2, 3, 4, 5, 6, 7. The one not appearing 8 times 2, which is 16. So it will be 16 plus 1 times 25 over 100. That's actually 17 over 4, because divided by 25 is 1, divided by 25 it's 4. So it is 17 divided by 4, and 17 divided by 4 will be equal to 4.25. Now, what does that mean? That means your first quarter location is 4.25. So we just come and calculate. This is 1, that's 2, that's 3, that's 4. So here we have the element which is more than 4. So what we need to, how to find the first quarter? To find the first quarter, it's not 4.25. This is the location. To find the first quarter, we should do the following. We should go to the elements before that one, which is 6. So we should say 6 plus. 6 is actually number 4, the element number 4. So that's why we selected 6. Plus what? Plus only 0.25 times the difference between 6 and 8. So it will be 8 minus 6. So that will be equal to 6 plus 0.25 times 8 minus 6, which is 2. So that will be equal to 6.5. So the first quarter is 6.5. Similarly, the next question, he's asking about the same thing, so I'll get the same order. It's the same question, so same elements, so it will be 5, 5, 6, then 6, then 3, 8, then 2 times 9, 1 times 10, 11, again 11, 14, 14, 15, 16. So these are the elements in order. What he wants here, he wants the third quarter. What is the third quarter? Means 75%. So regarding the location of 75, remember the formula we had, LB is equal to N plus 1, the percentile divided by 100. So if I want L75, that will mean we have number of elements is 16, so it will be 16 plus 1 times 75 over 100. That means 3/4. So it will be 17 times 3 over 4. 75% means 3/4. Okay, so if we calculate that one, 3 times 17 over 4, you will get 12.75. What does that mean? That gives you only the location. Location is 12.75, which means I come here to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12.75 means here. So we do the same thing. Q3 will be the elements before, which is 11, plus, here we have not 0.25, we have 0.75, so it will be 0.75 times the difference, 14 minus 11. So that will give me 13.25. That is what we call it third quarter. Quarter is 13.25. It's not what we call it 12.75. I hope that will be clear enough for you. Next question is related to the same calculation. We have the first quarter is 6.5, and we have the second quarter, it's 13.25. I write them down here. So the third question here, it says for the same numbers. So I will say, see the calculation in question number 29, where we get the first quarter is 6.5. And the question number 30, where we get the third quarter, it's 13.25. Now he's asking about what? Interquartile. Interquartile, you have to know this word. This means the difference. Interquartile, it's the difference between third quarter and the first quarter. So that will be 13.25 minus 6.5, which is equal to 6.75. So the answer is D. That's regarding calculation of first quarter, third quarter. And remember, the second quarter means 50%. So you do the same thing. You find the location, then you find the second quarter. So we have first quarter, which is 25%. We have the second quarter, which is actually the mid. The mid is 50%, and the third quarter, which is 75%. These are most important ones, but he could ask you about L10, which is 10%. He could ask you 40%, any percent, using the same formula. LB is equal to 1 plus n times the percent he wants divided by 100. So if he said L10, means you replace here 10. If he said 20, means you replace here 20, and so on. Most important ones, or most famous ones, are first quarter, third quarter, and the quartile, which is the difference between them. Now we move to important topic, which is a probability. The probability, we have certain rules, we have to know them, and I will go to each one when we discuss the questions. Here it says here a sample of 200. So we have the number of people is 200. They gave me in the statement and in the figure here the what we call it here Venn diagram. It says those who go to Disney is 0.6 probability. And those who get to Bush is 0.5, and there is also some people here, they go to both of them. And what he wants the probability visiting Disney or Bush. Now here we have to be careful, because these are not mutually exclusive. There is something common. So here it's not mutually exclusive. We have two events which they are related to each other. There is a common between them. That's why whenever we have probability of A, let me call the first event Disney, I will call it D, stands for Disney, the event Disney. And let me call B for the event Bush. So what we want, it's probability of Disney or push. That is the rule. If we have not mutually exclusive, it will be probability of Disney plus probability of the Bosch minus probability of Disney intersection with Bosch, or we could say D and B. It's the same. Intersection means and. So probability of Disney, it's given 0.60. Probability of Bosch, it's given to me 0.5 minus probability of the common, which is given to be 0.3. So if we calculate that one, what we will get? We will get that is 0.8. So what's the choices he given to me here? So I choose the answer, which is 8. Here is another example, another question about probability. Okay. That was question number that's the one. Anyway, here it says a sample of employee of worldwide enterprise to be surveyed about a new health care plan. We get this table of data. The classification, we have supervisors, we call them event A, we have 120 employees. We have maintenance, we call them B, the event we call it B, and it is 50 employees. We have production people in the production, we call it the event C, and we have 1,460. We have some people in the management. We call this management event D, and that is a 302. Secretarial means the secretaries. We have E, we call them E, and we have 68. So first of all, we need to calculate the total number of employees. If we calculate the total number of employees, we add up 120 plus 50 plus 1,460 plus 302 plus 68. That is 2,000. Now, let's go to answer the question. Here it says the employee are classified with the what he want. He said here, I want the probability that the first person selected is either maintenance or secretary. We say probability of either maintenance. What's maintenance? Maintenance is B, or secretary. Secretary, we say it's E. When we say probability of B or E, we say that's the probability of B plus probability of E. Some of you will ask, what about minus probability of B intersection E? We don't have this. There will be no guy who is working in maintenance and secretary. Maintenance is one job, secretary is another job, so there is no intersection between them. These events, in another word, these events, which is B and E, we call it in probability, are mutually exclusive, not related. There is no intersection between them. These are mutually exclusive, means intersection between B and E is nothing, is phi. We call it in math phi is equal to phi, means empty set. There is no intersection between them, no intersection. So anyway, what's the probability of B? Probability of B, it's the number B divided by the total, which is 2000. What's the probability of E? It's the number, which is 68, divided by the total. That will be equals to 50 plus 68 divided by 2000. That would be 0.059. So the answer here is A. Same question, but we change, same data, but we change the question. So we say that's 2000. We just calculated. Now, here he said, what's the probability the first person selected is not management? That is speaking about complements. When I have complement, what do I mean by complement, guys? Complement, if this is the event A, and that is B. What's a complement of A? Or let me, if I have here a space, complete space, and I have here, this is A. This is, we call it not A. This is, we call it complement. This is, we call it complement of, we have two ways to write it. Complement of A, or some books they call it A bar. This means complement in the field. Not A. This means not A. Okay, so here he wants not management. So to find the probability of a complement of A, let me say here, since he used management and he said the management is D, let me say here D. And let me say that's not D, and that's D complement, and not D. So complement of D, it's equal to 1 minus the probability of D, which means if I want to find not management, I need to find first the probability of management. So probability, that will be equal to 1 minus probability of D. D, it's 302 divided by the total. So always when we want to find the probability of the complement, we say it's 1 minus probability of D. So that will be equal to 1 minus 302 divided by 2000. So it's 2000. So that will be equal to 0.849. Now, next question again about the same sample, but the question is different. Now he's asking about the event of maintenance, which is B, which is maintenance. And the event of the secretary, which is D, secretary. Are they complementary? Are they complement of each other, or mutually exclusive events, or both? Okay, or 0.8. Now, when we say complementary, it's wrong, because the complement of B, all the rest, which is A, C, D, and E. So we cannot say complementary. We cannot, if we cannot say complementary, of course, we cannot say both. So the answer will be that it is mutually exclusive. They are not related events. Those who are in those who are in maintenance, they will definitely not be a secretary. Secretary has a job, maintenance has another job. So we call it mutually exclusive because this is B and that is E, not related. There is nothing in common. When they are not mutually exclusive, there is something common here. Okay, so the right answer, mutually exclusive, means no common elements. No common elements in between. Okay, now let's continue for the next question. The next question says here, the National Association of a Theater of 500 selected people, they were surveyed and they are asked about their age and the number of movies they have seen last month. And they give you a summary table here. That's the summary table. Let me just get the statement, what he wants. He wants here, what is the probability of selecting an adult who's attended 6 movies or more? So we need to have an adult attending 6 movies or more in the table. So if we look in the table to understand it first before we go to the solution, they ask several people about 2 things, not one thing, about their age. Some of them they said they are less than 30. Some of them they said between 30 and 60, and some of them they are 60 or more. Now, those who said their age is less than 60, we call it events B. Those who said between 30 and 60, they call it event B, 2. And those who are 60 or more, we call it events 3. So how many of them they said 30 or less? We have here 15 plus 25 plus 55 plus 5. 100 of them, they said it's less than 30. 125, which is here. And because they were asked 2 questions, not one. Now, the second question is, how many movies they have watched last month? So 0, the first event, they said they did not see any movie. We call it A. They see a 1 or 2 movies. We call them A2, and so on, 3, 4, or 5, and more than 6, day 4. Of course, there will be common intersection between the two events. Now, let's go to answer the several questions about this table. Each time we will change only the statement, which is this one. Let me highlight this one. He wants the probability of 6 or more per month. 6 or more. Now, if we go to 6 or more, where do we see 6 or more movies? He's not speaking about the age now. He's speaking about 6 or more movies. Who said I have done 6 or more? 50 of them. 50 of people. They answer, they watch 6 or more, because these are 5 means what? 5 means they are less than 30 and watch 60. 15 means what? They are between 30 and 60 and watch 6, and more than 60, 30 of them who are 60 or more and watch 60 movies. If you calculate them, you get the total here, 5 plus 15 plus 30, that's 50. So anyway, our question is, how many people who watch more than 6 films? We have 50, so we will say the probability is of watching 60 or more, 6 or more, it will be 50 divided by 500, which is 1 over 10, which is 0.1. Actually, that's the event A4. You can say the probability of A4 who watch 60. It's A4. So we have, it's supposed to be 0.1, but here I have to correct it. I thought I have correct that one, but I forgot it. Anyway, let me put it to the black. Supposed to be here, it's 0.1. So the right choice will be, the right choice should be C. Now, same question, but here now he's asking about what's the probability of selecting who attended 2 or fewer than 2. That is very important to notice. When we say 2 or less, where do we see 2 or less? This is 1 or 2, and this is no. So 2 or less means either A2 or A1. That is 2 or less. So probability of 2 or less means probability of A1 or A2, because A1 means they did not watch any film, and A2 watch means 2 or 1. So when he say here, what's the probability of those who are 2 or fewer, means 2 or less, means either 1 or 2 or 0. So that will be probability of A, or probability of A1, or probability of A2. So which means it will be probability of A1 plus probability of A2. Of course, there is nothing common between A1 and A2, so that will be, they are mutually exclusive, A1 and A2. So we will say A1 has 75 over 500, and A2 is 200 over 500. So the answer will be 275 over 500, which is equal to, you calculate that one, it's 0.5. So the answer here is same question, but again, same data, but we change the question again. It's the same data, but now he's asking about what? The probability of selecting adult who said 6 or more movies. This is one. FM. Burma. Given the person is 60 old. He is speaking now about conditional probability. Conditional probability, it says the following. When you have a conditional probability, what's the rule? Let me write the rule for you in black. Conditional probability, when I have probability of, let's say, A given B, put in black. So the rule says the following. Probability of A given B, it's equal to probability A intersection B, which means and A and B divided by probability of B, which is probability of that. Now, let's see what he wants here. He said the probability of selecting an adult who watch 6 or more movies. Which one has 6 or more movies per month? It's A4. So he wants probability of A4 given the person is 60. Person is 60 is what? A person has age 60, it's the event B3. The event B3 is 60 or more. So that will be the probability of A4 intersection with B3 divided by probability of B3. What's that one equal to? Probability of A4 intersection B3. You go to A4. I'll use the highlighter. This is A4 and intersection with B3. We go with B3. What's the intersection? The intersection will be 30. So that is 30. Divided by, of course, 30 over what? Over 500. Divided by 500. Now, probability of B3. B3, what is it? B3, it's 175 over 500. And that will mean what? That is 30 divided by 500 divided by 175 divided by 500, which is actually 30 over 500 times upside down 500 over 175. So these will cancel, you will get 30 over 175. That will be what? If you calculate 30 divided by 175, you will get in your calculator 0.1714285714. And as we said, if we look in the choices, it's only 2 digits. So 2 digits, we look in this number. If it is less than 5, we just say that is 0.17. So the answer is 0.17. Okay. Now, let's move into another question with the same data again. Here we go. Here it says, let me highlight it. He wants the probability of an adult who has watched 6 movies or more. And here, some of you will confuse between 2 questions. I will highlight this one. Here, guys, here he said what? And that's a question number 40. Question number 38, what did he say? 38. Don't confuse between 38 and 40. 38, he said what? The word 6 or more movies and what? Here the word what? Or. Or is different from and. And has a rule. Or means addition. And means multiplication. So here we have our question. It says and. and probability of an event A and B, it will mean probability of A times probability of B. It's and means multiplication. When he used and means multiplication rule. But if he used between the two events or, that is addition rule. So multiplication rule is and, or means addition rule. So let's solve our question. Here it says he wants 60, probability of 60 and 6 movies. He said probability of 60 and that's question number 40. Question number 46. Probability of 60, what's the event of A60? That is B3. So he wants probability of B3, in another word, and A4, which is watching 6 films, and he is 60. So that will be probability of B3 times probability of A4. So that will be equal to what? Probability of B3, and we could have it here actually immediately, and means intersection. In another word, that's a probability of B3 intersection A4. What's the intersection? We find it this way, guys. We need B3 we need it B3 intersection with that one. So it will be what? The answer will be 30 over what? 500. So that will be equal to 3 out of 50, because 0 will cancel with 0, and that is 6 over 100, which is 0.06. So the answer should be E. Okay. Now, we move to same thing, same idea, but we change only the data. Now, our data is different, but we are still in a probability. We are reviewing probability. Here it says, suppose a study of speeding violations and the drivers who use cell phones produce the following data. Of course, he gave me here a table. Now I need to know what he wants. He wants the probability of he is not a car phone user. Now, let's understand first of all the table, then we will go to the questions. Here we have two things. We have speeding violation last year. Those who get speeding violation, we have here two categories: having speed violation, not having speed violations, and we have cell phone car, and they don't have a cell phone car. So those who get violations 60, 20 of them they have cell phone, and 40 of them they don't have a phone, but still they have a violation in speed. They don't have a speed violation. 275, they have a cell phone. 400, they don't have a cell phone, but 675, they did not get any ticket last year. The total number of people under the survey is 735. This total is for those who has cell phone is 295. The 440, they don't have a cell phone. 60 get violations, and 675 they did not get a violation. Let's now solve several questions about this table. Here he wants the probability of not, if not, the probability that he is not a car phone user. He don't have uh, a cell phone. Which one has no cell phone? It's 295. They don't have phone. Here you can see that is cell phone. Oh, sorry, that is not. He has not means 440. So he has no phone. So what's the probability? Let me call this one A, not having a cell phone. So probability of A will be, of course, not having a cell phone. It's 440 divided by the total, and that will be equal to, if you calculate 440 divided by 735, you will get that's equal to 0.5986394558. But anyway, he gave me as a fraction 440, so I'll just choose it. If he put it in fraction, we will choose, sorry, in decimal, we will choose the decimal, but since he gave in a fraction, we will choose the fraction. Sometimes in the choices, we put it in. Now, it's the same data as I said, but we change the question. Here we want the probability that he has speeding violations in the last year car phone has speed violation. Who gets speed violation? Those who get speed violation. These get speed violations, 60 of them. So let me call it here again. B is the event speed violation. Speed violation. People who get speed violation. So he said find the probability he had a speed violation last year. So what's the probability of B? It's those who get violation, which is 60, divided by the total, which is 735, and that will be the answer if it is given in 60 over 735, and if he give you an decimal 60 by 735, you will get it's that is 0.081665 and so on. Of course, he might give it to you in 3 digits. If it is in 3 digits, will be 0.08. We look here 6, we say that's 2. That is if it is written in decimal. Same question again, but we change only what we want. The probability that he has a car phone user and had a speed violation. It's 2. And he said what? And so we go to the first event, which is car phone user. Where is car phone user? That is cell phone user. And he get what? Speed violation. And the speed violation. So where is the common between them? That's the one. So it will be probability of having, let me call this one A, and that's B. So probability of A and B is equal to 20 over 735. 20 over 735. If you want it in decimal, that will be 0.0271088 and so on. So if he made it 3 digits, that will be 0.027. Anyway, he gave it to you as a fraction 20. There has to be 20 over, that's the one. Question number 44. Question number 44. It says here, again, it's the same data, only the wanted is the probability that is not a phone user given he had a violation. So we have two events here. The first event, not a car phone user, not a car phone user, not a car phone user. That's, we call it A, for example. And the second one, he had a violation last year, had a violation, speed violation. This is, we call it B. So what he want, probability of A given B. So that would be probability of A intersection B and B divided by probability of B. What is A and B? A and B means this is A and that is B. So A and B means 40 over 735. Probability of B. What is the probability of B? It's 60 over 735. And that is actually, we cancel out these two, we get 40 out of 60, which is 2 over 3. So the answer is 2 over 3. The last question, is it last question or before the last? So we finish 44. So question number now 45. Okay, 45, what's the question? The probability that he has no violation last year and he was given he was a car phone user. Now, let's see what's our events. Our events are, the first event, he had no violation. He has no violation. Oh, sorry. That's, he has no violation. That's the event, we call it A. That's A. Now, and the second has, has no violation, and he was a car phone user. That is, he has a car phone user, a cell phone user. So that's a car phone user, and that's, we call it the event B. Okay, so what he want? He want probability of no violation, which is A, given a car phone user, he was a car phone user, which is B. So what we say, it will be probability of A and B, intersection B, divided by probability of B. So that will be equal to the first one, which is A. A is no violation is 675 divided by 500. Sorry, divided by 735. And the second, sorry, we need the intersection between A and B. The intersection between A and B is 275 over 735. Probability of B. B, what is B? B, cell phone user. Given cell phone user, it's 295 over 735. So that is cancelled. So we get 275 over 295, and that will be equal to 275 over what we say, 275 over 295. That's the answer. 275 over, it has to be that's question number 45, right? It's 275 over 295. I think I have missed that one. So the probability is 275 over 295. 275 divided by 295. That is equal to 55 over 59. Anyway, not both of them are written, and it should be 0.9322. I have to correct this one again. This should be, let me change one of them. 5 over 50. Anyway, it's a typing mistake again. But the right answer is either he gives you this one or that one. Now, the last question we had in this review is what he wants. He said the probability that he has not a phone car user. Not means complement. So first, I need to know what's the complement of which event. Where is the car, not a car, that he has not a car phone user. Anyway, that's the its event here. If we call this one A, this is not a phone user. So what is not a phone? That's a question number 46. If a person is selected at random, then the probability that he is not a car phone user, not a cell phone user, it's 440. It's 440 divided by 735. So the answer is, that will be the end of this review. If you have more questions, you may send it to the group, and I will type them, and probably tomorrow I will solve them if I get any question from your side. Thanks for listening. So we start.